Welcome back, students. Now we are going to discuss the next important process called as Gabriel Thalamide synthesis for preparations of amines. Let's start with the process. Now, Gabriel Thalamide synthesis is also referred as alkylation of thalamide. The first question arising, what is thalamide? Let's try to answer this. It is a compound in which there is a benzene ring attached to C double bond O, that is 2C double bond O, and both the C double bonds O are attached to NH group. So this is nothing but a molecule of thalamide. Now what we are going to do with this? Let's see. Now the first thing we need to notice here is the H which is attached to nitrogen is an acidic hydrogen. So if we happen to add a base, let's suppose KOH, what will happen? H and OH would combine because OH is nothing but basic in nature. So what would happen? H and OH both would combine, giving rise to a water molecule. But as nitrogen is more electronegative than hydrogen, he would take away all the electrons while breaking the nitrogen and hydrogen bond. So what you obtain is nitrogen with a negative charge, potassium with a positive charge. So obviously what you would get is nothing but a salt of thalamide. Let's see that. Firstly, what you have is nothing but benzene ring attached to C double bond O, C double bond O 2 times. Then nitrogen with a negative charge and potassium with a positive charge, and thus we would say this entire salt as potassium salt of thalamide. Now further, if this potassium salt of thalamide was treated with RX, let's see what do we get. Here what would happen is alkyl halides, which are polar in nature, would attack onto their respective groups. That means negative over positive and positive over negative. So let's see this. Nitrogen attacks over to the R. This is nothing but a substitution nucleophilic reaction. Next, this R and X bond is broken down, giving us KX as a product. So what exactly we are remaining with? The thalamide ring, but now in this N is attached to R. That means, is this thalamide? No, this is alkyl thalamide. So if you have NH, it is thalamide, but now you have NR, so it is alkyl thalamide. Moving further, what we would do with this? Now, this alkyl thalamide, further, in this case, the nitrogen is directly attached to R, therefore we would require to write N-alkyl thalamide. Next, if this N-alkyl thalamide was treated with dilute NaOH, let's see what happens. We go for a process called as hydrolysis, and in this case we would require 2 water molecules. So what happens is both the C double bond O bonds, that is C double bond O getting attached to N bonds, are broken down, and you left down with a compound that is sodium thalate. Along with this, what we happen to get is nothing but N, 2 hydrogens and 1 R. That means, is it NH2R? And this is nothing but a primary amine. So yes, we obtained a primary amine from this. Now, the very crucial point over here is, what are the advantages of this method? The first advantage is over-alkylation is avoided. That means you would never ever get a secondary or a tertiary amine. The next point is the limitation of this method. The first limitation is aromatic primary amines cannot be prepared by using this method because aryl halides do not prefer nucleophilic substitution. They prefer electrophilic substitution. And the last point which we would state over here, the most important one, in this method we can only prepare aliphatic primary amines. We could not prepare anything else. So now this was the entire process. Let's understand what we have the knowledge about this process with a simple MCQ. The MCQ states Gabriel Thalamide reaction is used for the preparation of what? So let's start with the solution for this. We said that in this method, that is in Gabriel Thalamide synthesis, we can only prepare aliphatic primary amines. Therefore, the correct option over here is option B, that is primary aliphatic amines. This was all for this module, students. Meet you in the next module. Till then, thank you.